Thanks everyone for being here. My name is Emma Marshall and I'm a PhD student at the University of Utah, so I'm really excited for the opportunity to be here with you all at CNG this year. And I'm going to be talking about some work that I've done with my co-authors over the last, it's kind of like spanned a couple years, but then in the last also couple months, work developing an educational resource to demonstrate cloud-native geospatial DataCube workflows using Xarray and Zarr. And I'll just note, so my research, my academic research is more focused, on using Earth observation data to quantify and better understand glaciers in high mountain Asia. And so that's kind of how I came to this problem. And then over the course of my PhD, I've gotten more and more interested and curious about like kind of the tools underpinning how and enabling our scientific research and the resources and kind of community infrastructure that like make this robust community. So I don't think I need to convince anyone in the room about kind of the pressing need to, or the situation we're in, which is the increasing availability and complexity of Earth observation data. And we have also increasing tools to work with and make sense of this data, but it does place a pretty high learning curve at times on users, as we've already talked about and heard today. We're also wanting to do all of this work in following the principles of open science so that we're producing robust, reliable, representative, and impactful scientific research. So I thought this quote from Julia really summed it up very well. There's a growing gap between the amount of open Earth observation data produced every day and then the ability of users to find, access, and process that data. And that's a real rate limiter to our ability to maximize both the public benefit and the scientific benefit of Earth observation data. And thankfully, as I was kind of like setting out to develop resources like this, a lot of folks who came before me have already done a lot of research into like what makes an effective educational resource. So we had a lot of guidelines to look to when we started this. We know that we need educational resources that deal with real-world data sets and they don't gloss over the messiness of real-world data sets. We also want them to balance text and code and use notebook best practices. We really want them to be flexible and participatory. And we want them to combine a discussion of data formats and physical meaning and interpretation of the data. And so that specific point came out of a paper that was talking about like capacity building for conservation scientists. And I thought it was a really good point and something that I think is brought up a lot but not always explicitly stated. And I want to complicate it a little bit by saying that we need to connect and include discussions of data formats, how it's stored, to the physical meaning of the data, and also the in-memory representation of the data and how we work with it. And then chiefly, and like especially relevant to this conversation, is that we want educational resources that reflect the modern data and compute landscape. So that means that we're working with larger than memory data stored in cloud object stores, cloud native data types, and we want to really make use of in building the resources and then also highlight throughout the resources the suite of open source tools that exist. So this is like a kind of overview of what we're trying to do, and I think I glossed over some of the motivation in addition to like this need that I think we all have experienced and felt, is that this at a very broad level, and then also in kind of like a smaller scale in discussions in Xarray, like various kind of Xarray spaces and Pangeo showcase discussions. The point was brought up that sometimes the hardest part about teaching users to work with Xarray and to use Xarray is kind of like, how should we use this? Like, how should we, like, what we have this tool, but how do we actually connect it to like the things we want to do? And so that's really something that I think we wanted to focus in on here. So with that kind of introduction, I am excited to share a educational resource that we have developed. This started during an internship that I did like after the first summer of my PhD, and then it's kind of morphed and expanded into different things, and now it is a book that contains two Jupyter Notebook-based, it's a Jupyter book that contains two Jupyter Notebook-based tutorials, each focusing on a different satellite remote sensing data set. And I'm going to talk more about it in a second, but I wanted to put it up here, and please feel free to like scroll around the book while I'm talking, and I'd be like really happy to discuss any like questions or feedback that people have afterward. But so just two quick things about it are that, so it's two distinct tutorials with some additional information. And one thing that's really important is that we want this to be participatory and interactive. So it contains detailed instructions for like recreating the environment needed to run it on a local machine or a hosted Jupyter hub. And then also like most of the data you're accessing in the notebooks, but there's a couple like auxiliary data sets and how you download that. And so like kind of drilling more into like what we wanted to develop. We know what we want effective resources to look like, and so like what did that translate to in thinking about like what we wanted this resource to be. We really want it to be accessible and reproducible. Those are kind of like absolute necessities of this, and we want to highlight publicly available data. This is like the whole point of what we're doing, right? And this is like a big part of maximizing the public benefit of these data sets that are so exciting. Also highlighting the suite of open source tools. And then I think kind of chiefly, and what I want to talk about in the next couple of slides is like what we hope, the effect that we hope these tutorials can have. And that's like a little bit different from just like a teaching to code perspective. And and like taking this quote that I'm about to say from the Journal of Open Source Education, where they talk about learning to code versus coding to learn. And I think a goal of these books is to really promote a deeper understanding of the material and the tools that we have to work with it. So kind of connecting the how and the why. I'm going to talk a little bit more about like how we tried to do that now, but I first wanted to spend a couple minutes talking about some ideas that like really informed my thinking developing these. And I owe Deepak a big shout out for turning me on to the article like version of this talk a couple years ago. And it's a really great both like video of the talk, and then there's an article that associates it, or that accompanies it. But this really connected with me in a lot of ways, and it was helpful thinking about these things. And this is the concept of computational learning from Lorena Barba. And it's kind of the idea that like computing in itself and how we use computing in science, it creates knowledge. And that how one would like create knowledge internally is through experiencing something. Like we can't just transfer knowledge from someone without that person experiencing something to gain it. And that's really what we're hoping to facilitate with this type of resource, is that we want to decouple from a classroom environment, create a resource that could like facilitate a user having an experience that really helps them learn something. And so a couple other like notes and framings from this talk that I found really helpful are that science is a conversation. So she's quoting Stephen Downes in that phrase. And then I really liked how she kind of like clarified it to the context of computational workflows, is that computing interactively is a conversation with the system under study. And I think that's like really encapsulates so much of what we're trying to do. And I think a lot of what in a kind of asynchronous, distributed, like, or kind of publicly accessible resource like this, like what we could be trying to emulate or like help recreate. So that was really like a guiding or driving question for me thinking about this, is that we want to facilitate the user having an experience that would help them learn language so that they can have their own conversation with their own data set and express themselves that way. With that, I'm going to just like pretty quickly gloss through a couple ways that we tried to achieve that within the book, and definitely some of this is aspirational, could always improve it, but we like just a couple brief examples rather than going through the whole book because I don't want to bore anyone, but of how we tried to use these examples to demonstrate deeper understanding. And so the first is always really focusing on connecting the data model, the physical meaning of the data, and then the data storage format, and how you kind of interoperate between those different like states to suit your purposes. And that is a lot of like reading, writing, and using cubes. There's already been a lot of discussion of data cubes here, and this really is like, I'm looking at workflows where cubes are the ideal, I think, like expression or format to think about and use this data. So a lot of the examples in the book, we start with 2 introductory and background sections that precede the tutorials. In it, we're introducing the concept of data cubes and what they are, what analysis-ready data is, what does it mean to prepare data for analysis, which is kind of like the idea of data tidying, but that can look like all different things depending on what you want to do with the data or the questions that you want to ask of the data. So we really try to demonstrate kind of like some base examples of what that looks like. And then once we've built those cubes, now we want to ask more questions of it. And those questions that we want to ask require different structures different cubes and different structures of the data. So this is one example from the first tutorial of the book that focuses on it's a ice velocity time series data set that's generated from satellite image pairs of both optical and Zarr imagery. And so we have it, in this example, we have like a large swath of a raster time series with a large swath and spatial extent of this velocity data. And we're really only interested in it in a couple spatial features. And so what we do is we like talk through and demonstrate going from a raster data cube and a vector data frame to a vector data cube where instead of x, y time dimensions, you have geometry and time dimensions. And then once we have that in memory, that's great, we can use it, but we want to like have it exist beyond that kind of instance of a workflow, and so we need to write it to disk. Zarr is a really great tool for that, and so we talk through how you can do that with Zarr and encoding those geometries. And that's thanks to the work of so many people in the open source community. So as an aside, stepping out of like this talk, just as a PhD student, thank you all so much, because you've like saved me probably weeks of time, and it's really amazing. So XVec and vector data cubes within the Xarray data model are a really exciting development that we wanted to highlight here. One final one is, this is just another example of how we'd want to reshape cubes, but really like connect what we're doing, which is, in this example, in the second tutorial, we're looking at Sentinel-1 RTC data. So that's data that has already undergone a radiometric terrain correction process, and there's different ways that you can do that. So there's different versions of RTC data. And this tutorial demonstrates working with both of them. One is developed by Microsoft Planetary Computer, and it's accessed as COGS. And the other is processed by Alaska Satellite Facility's cloud processing platform, and then downloaded locally. So we have notebooks that demonstrate the workflows to like get both of those data sets to a workable data cube format. And the spoiler is that it's like much quicker with one of them than the other in like that way of doing things. And then ultimately what we want to do is look at a comparison between them. But what we try to do is zoom out and say, like, rather than, like, okay, we want to compare these two data sets, like, what does that mean for the underlying shapes of the data that we're working with? Like, what would a comparison look like? And so we use the example of, well, the cube that would facilitate that comparison has another dimension, and that is how you can do that comparison, and you can make, like, doing it in that way that works within the data model, the Xarray data model and the Xarray tools actually makes that comparison much easier and much smoother, and so we try to demonstrate that. And just some final thoughts. I know I went through this quite quickly, so apologies. I didn't want to go through the whole book because it's quite long, but I did just want to emphasize like what I was thinking about using it and what I was thinking about developing it, and then what I hope like might be helpful to learning users who might use it. And that's really emphasizing the details, but also zooming out and focusing on the fundamental principles underlying the example. So we include a lot of background about the data sets, how they're generated, how they're accessed, various things that you need to look at to understand and interpret that data appropriately. So getting into the nitty-gritty details of, like, is it an ascending or a descending scene, things like that. But also zooming out and saying, like, on a very fundamental level, like, what are the dimensions of this cube? What dimensions do we want it to be to answer these questions that we have, and how do we perform that manipulation? And ultimately, I think, to go back to the idea of computational learning, the goal here is really to introduce users to a set of tools that will empower them to express their own analyses and have the conversations that they want to have with different data sets. Some references, and I want to acknowledge everyone in the open source scientific software community who has worked on and contributed to the tools that were used here, the documentation of those tools that I learned a ton from, the dataset developers and maintainers, and then so many people who I've had conversations with, and my co-authors throughout this process. Because it was a big learning experience for myself, and I hope that it would be helpful to anyone who's hoping to kind of get started working with Earth observation data using Xarray and Zarr. And I would be really happy to take any questions now.
Yes. So this is less so a question, more so of a comment that could help on maybe some of the more educational stuff you're talking about. A couple resources that I've used in the past were the Pi OpenSci community and or the University of Colorado Boulder. They're very similar ideologically in terms of open data, reproducible, open science, things like that, kind of you touched on. So those could be a couple resources that may aid in some fashion for you if you haven't discovered those yet. So I figured I would mention those to you.
Definitely, thanks. I think, I was just having a conversation with lunch about like all of the different resources that are out there and how it can be like kind of a tough thing to even curate that. And thanks for those. I've worked with some of them, but not all, like some of the UC Boulder ones. Project Pythia is another one that I just want to champion. Like everything that Project Pythia has produced is really amazing, and looking at like the formatting of like what their cookbooks look like, I think they've just like set a really high bar and have a great process. So thanks for that. Yeah. Oh, sorry.
Thank you, Emma, for your great talk. I was wondering, as you just mentioned, Project Pythia allows you to run the notebooks in the cloud. Does this Jupyter Books or this publication allows you to run the material in the cloud?
So we don't have that capability. I think it would be really cool to implement, and we did at one point have a binder instance for the It's Live for one of these tutorials. It was kind of like, it was difficult to like manage and keep up and like keep working. So we don't currently have like a way that someone can kind of like just go interact with it in that way. I think that would be really great. There are some difficulties with the data and things like that and where it's being accessed from. So what we do have right now instead of that is, so we have instructions for like creating a local computing environment using either Conda or Pixie, and then also creating like an environment on a hosted Jupyter Hub. We've tested it on CryoCloud so far, which is a resource for cryospheric scientists, like a hosted Jupyter Hub. I haven't tested it on other ones yet.
Great. And then, can I make another? Yeah. Following up question, it could be possible to translate this into a Jupyter Codebook and then get that functionality, if we can call it that way?
Into like do you mean like
the book into a Jupyter Codebook, and then probably use their resources, their like. Yeah,
and so I should have. Thank you. And maybe I didn't mention, but so the like framework that we use to build the book is a Jupyter Book. So it's part of the executable book project. So it should, like, I hope it would be informative for someone who just wanted to like read through it on a browser. But then the files are all, like the underlined are all Jupyter notebooks, and so you could clone the repo associated with the book. So I guess the QR code I have goes to the Jupyter Book, and then there's a GitHub symbol that would be the repo. But definitely a goal of this, and like how I hope people would use it, is to clone it and then open it up in their own Jupyter lab and like change things and do what they want with the notebook. So yeah,
Great.
I hope so. And I would like love feedback on like how effective or not effective that is.
Great, thank you.
Thanks.
Hi, great talk and also great project. So I really like that slide where you were talking about like this goal of creating something so that the users can have their own conversations. And their own discussions with data. So I think as somebody who also creates learning material, one thing that I kind of struggle with is how do I measure whether my users are able to use this to have their own discussions. And so I wonder if you could reflect on that, maybe either experiences you've had, if you've seen how they've used it, or thoughts, if you have thoughts on how do we measure this, the impact of what we're creating.
Yeah, definitely. Thanks for that question. I think it's a really important one, and I agree, like a tricky one. And something that I have thought about while I've been working on this is, like part of the whole goal of this is to like have these tools and these resources be accessible, like more accessible than something that you need to be in a university course to pick up, right? Like that's the whole goal, is to not have that be a necessity. And in some ways, but we're trying to like, at least something that I was thinking about when I was working on it was like trying to include narrative text that would maybe be similar to like what might be covered in a classroom discussion, but might not necessarily be on like the slide. like just the little questions that come up, and try to actually spend the time explaining them. But then like the question of like measuring the effectiveness and efficacy of that is tricky. My first impulse was to say like, well, I've shared this type of book when I've been like assisting in a course, like a active remote sensing course, and we worked through the Sentinel-1 book, which was great. And I got a lot of feedback. Like, it was a really good experience for me to be like, oh, I just like thought it through it this way, and then I gave it to 20 people, and they everyone saw it in a different way. But then again, we're like back to like relying on a university course model. I would really love to see more, like, I think this is already a GitHub-based project where like this whole, the repo that like is the active version of the book is available and public, and I think GitHub discussions and issues could be a great way to do that, but I don't think it's like, it would create a lot of kind of like work and community building and probably some like structures to really invite that type of engagement, and I don't know like the answer to that. But that's my first thought, is that I would love for it to happen on GitHub or something similar, just because I think enough people are already there. And if they're not, it's a good place for like learning users to spend more time. That's my perspective as a continually learning user and someone who was very new not too long ago. But thanks.
Yeah, thanks for the great presentation. I was just curious, you had a slide there about doing vector in Zarr. I was just wondering what type of vector geometries you were actually capturing in Zarr, and if you had more than one application in mind, how that could be used.
Yeah, thanks for the question. I think so. This example was just showing, we really wanted to highlight like the functionality of XVec, which is this new package in the Xarray ecosystem, specifically for implementing this like a dimension of vector geometries. So in this example, we're looking at polygons, and we're essentially like sampling the raster cube and then performing some zonal statistics over the polygons. But it would work for points as well. So you could extract like any type of vector geometry. And then how it works is you use CF conventions. Essentially, you can't like write the, mine's drawing blank, but like the shapely polygon to disk or to Zarr. Right. So you encode it using CF geometries, which is like part of the CF conventions. Something I didn't talk about here, but is kind of another important influence, is just important factors. We try to stress like metadata conventions throughout the book, and how important it is to kind of understand metadata conventions and adhere to them wherever possible, because it opens up so many tools for you. And this is an example of that, where we're using CF geometries to encode the vector DataCube and then write it to Zarr and read it from Zarr. So you encode and then you read it and you decode it back to a shapely geometry.
And then ultimately you're enriching the Zarr with that data that came from vector, and you can combine it with...
Yeah, once you encode it to the CF geometries, it's like readable by Zarr as like another array data format, but it has all of the information it needs to round trip it back to a shapely polygon.
Very good, thank you.
And I should say, yeah, that's like all the work of XVec and CF Xarray folks who really like made that possible.
Awesome, thanks.
Yeah. Okay. Great, thank you all.
Thank you.